Welcome back to Think Cosmos, where we ponder the universe's deepest secrets and wonders. Picture our Milky Way as a sprawling neighborhood, the sun in its cozy cul-de-sac, the local bubble as the widest suburb blown open by long-dead supernovae. And now, just 300 light-years down the street, a giant, glowing newcomer called Eos has rolled in. Astronomers first spotted hints of Eos when they combed through archival far ultraviolet maps from Korea's ESTSat-1 satellite. Those data showed faint ribbons of molecular hydrogen fluorescence, basically H in molecules absorbing high-energy photons and re-emitting a dim purple glow that most telescopes ignore. That ultraviolet fingerprint is crucial because cold He is normally invisible. It radiates almost no heat or light and usually betrays its presence only through trace carbon-monoxide lines. Yet Eos is practically carbon monoxide poor. Cold dark. That's why decades of radio surveys missed it completely. Follow-up work stitched together Galax, Finn's Spear, and 21-centimeter hydrogen maps. Then layered in a new 3D Gaia dust model called Distribution. The result: a crescent-shaped cloud roughly 90 to 140 parsecs away, stretching a jaw-dropping 40 full moon widths across the northern sky, about 20 degrees, big enough to blanket the constellation Draco if our eyes could see in far UV. Mass estimates land near 3,400 suns worth of gas. Only about 1% of that shows up in carbon monoxide, confirming most of the mass is hidden from traditional survey. Eos sits right on the outer wall of the local bubble, where million-degree plasma from ancestral supernovae slams into cooler interstellar gas. X-ray and O6 maps reveal the hot plasma. Eos casts a foreground shadow in those maps, literally outlining the collision front between hot and cold phases. That makes it a natural laboratory for feedback physics, how stellar explosions sculpt raw star-forming material. The cloud's average density is only about 30 molecules per cubic centimeter, nearly a vacuum by Earth standards, so gravity is barely winning. Modeling suggests ultraviolet photons from neighboring OB stars erode Eos at 600 solar masses per million years, 3 times faster than nearby regions turn gas into stars. Left alone, the entire cloud could photo-evaporate in roughly 5.7 million years, a cosmic blink, unless some passing shockwave or magnetic squeeze kickstarts collapse. That possible fate has big implications. For years, astronomers wondered why star formation efficiency in the Milky Way is so low. Now, we have a live example of a massive reservoir being whittled away before gravity ever gets its chance. If dozens more cold-dark beasts like Eos lurk nearby, we're missing a hefty slice of the galaxy's mass budget and misjudging how quickly gas cycles between cold clouds and shining stars. Burkhart's team argues their method could uncover many such ghosts once next-generation ultraviolet missions, like NASA's proposed SPHEREX-2 or LUVOIR B, scan the sky. Suddenly, the dark in dark molecular gas feels less mysterious and more like undiscovered real estate waiting to show up under black light. Zoom in on the cloud itself, and the structure gets even stranger. Dust maps reveal Eos is warped into an arc about 50 by 20 parsecs across, hugging the high-latitude side of the North Polar Spur, that bright X-ray radio loop you've probably seen in Milky Way panoramas. Simulations suggest the spur is a supernova-blown chimney channeling hot gas out of the disk. Eos may be an island of cool refuge caught in that outgoing flow, its edges lit up where 1,000-degree winds lick its surface. Temperature estimates place the hydrogen at 100-200 cold enough to stay molecular, warm enough that thermal pressure plus turbulence balance gravity. At those conditions, the gene's mass, the threshold for runaway collapse, hovers near the total cloud mass, meaning Eos is marginally stable. A small shove could fragment it into dozens of baby star cores, but without that nudge, it may simply dissipate. Discovery logistics are just as cool, because Finn's Spear's detector is optimized for faint ultraviolet glow, The team had to weed out air glow, instrument noise, and even far UV aurora from Earth. They then calibrated fluorescence intensities against laboratory HJ cross-sections to derive column densities, cross-checking with ground-based alpha-HI data ensured the ultraviolet stripes weren't just atomic gas. Finally, they triangulated distance using stellar reddening and soft X-ray absorption, dips along hundreds of Gaia-charted sightlines. The multi-probe approach sets a new standard for mapping invisible matter. Why name it EOS? Dawn Goddess, yes, but also an acronym joke. Emission-only source. The poetic symbolism sticks. The cloud literally glows faintly in the dark and heralds a new observational dawn. Artistic renderings show a lavender arc, arching above a city skyline, and if our eyes could see it, spectacle 40 moons wide that would dominate dusk skies. In reality, most of us will never glimpse EOS directly, but radio amateurs might pick up its small Sul knot catalogued as MBM40. Possibly a dense clump embedded in the larger skeleton. If MBM40 is indeed part of EOS, its 20 solar mass pocket is just a snowball perched on an ice floe. It underscores how misleading co-tracers alone can be. Looking ahead, astronomers hope to probe the cloud's magnetic field using Planck polarization maps, search for denser cobright cores with ALMA, and chase any nascent protostars with Jeb-Jebba imaging, mid-infrared imaging. A single Class 0 protostar would rewrite the too-late-to-form stars narrative, while a null result would lock in EOS as the poster child for photo-evaporating clouds. Either way, its proximity means unprecedented resolution. We can study processes normally hidden thousands of light-years away, right on our cosmic doorstep. So, a monster 3,400 solar mass hydrogen crescent has been hiding in plain sight, cloaked by its own darkness, until ultraviolet eyes exposed it. It reminds us that even our galactic backyard is full of uncharted territory, and that new tools can flip on the cosmic light switch, revealing giant structures we literally couldn't see yesterday. Keep your telescopes and your curiosity pointed skyward. The dawn of EOS may just be the first blush of a much bigger revelation.